The math class in Java contains method for performing basic numeric operations such as max, min, exponential, square root, and logarithmic as well as trigonometric functions. So for showing an example here, I have two numbers, first and second. Both of the number variables are of type integer. The first one is of value 5 and the second one is value second. First we'll try with simple functions like max, min, and then we'll go and do some of the other functions. If we need to get the max between these two numbers, we can say result is equal to math, and as you can see the math class is part of java.lang package. So we can do math.max, and for the max, as you can see, it returns the greater of two integer values. That is, the result is the argument closer to the value of integer.max value. If the argument have the same value, the result returns that same value. Meaning if both the argument has the same value, 5 and 5, it's just going to return 5. Otherwise, if it is 5 and 10, then it's going to return 10, which is the higher number. So here we can do first and second. And once we do that, we can do system.out.println, and we can print out the result. And if we compile and run this particular code now, we should see 5 in the response. And you can see 5 as expected. Now if we just change this to min and run, we should see 2. And you can see 2 as expected. Now if I go and change this to double, for the result. Let's change this to 2.5, and it's going to show 2.5 with the double as response. And you can see this is as expected. Now next one we can do is we can find out the absolute value. So if we do an absolute, and as you can see, absolute takes only one parameter, so we can pass second as the parameter. And now we can compile and run this application. We can see the value is 2.5. Now let's change it to minus 2.5. And this time also the absolute value should still return 2.5. And you can see absolute is 2.5 as expected. Now let's find out square root. So if we do square root, and this is, as you can see, returns the correctly rounded positive square root of a double value. Double value because my argument is double, otherwise it can be integer as well. If the argument is not a number or less than 0, then the result is not a number. So that's something important to keep in mind. If the argument is positive infinity, then the result is positive infinity. If the argument is positive 0 or negative 0, then the result is same as the argument. Otherwise, the result is the double value closest to the true mathematical square root of the argument value. So now let's do the square root, and let's use 25 here for the first, and let's pass first so that we can get 5 in the response. And if we compile and run, we should see 5 in the response, and we can see 5 in the response as expected for the square root. The next function that we can look into is floor and ceiling. So for, let's change it back to let's make it as 2.8, and let's try ceiling. So you can see that returns the smallest closer to negative infinity double value that is greater than or equal to the argument and is equal to the mathematical integer. Special cases, if the argument value is already equal to a mathematical integer, then the result is the same as the argument, which is expected. If the argument is not a number or infinity or positive 0 or negative 0, then the result is same as the argument. If the argument value is less than 0 but greater than negative 1, then the result is negative 0. So these are few things to keep in mind. Now let's try it out, and here let's give second, and let's compile and run, and we should see 3. So it is 3. Now let's try out the opposite function, which is floor. And floor, as expected, returns the largest closest to positive infinity double value that is less than or equal to the argument and is equal to a mathematical integer. Special cases, if the argument value is already equal to a mathematical integer, then the result is same as the argument. If the argument is not a number or an infinity or positive or negative 0, then the result is same as the argument. So let's try the floor, and let's compile and run, and this time we should see 2 as expected. Now apart from this, we can also try out the round. So round, you can see, returns the closest integer to the argument with ties rounding to positive infinity. Special cases, if the argument is not a number, then the result is 0. If the argument is negative infinity or any other value less than or equal to value of integer dot mean value, the result is equal to integer dot mean value. If the argument is positive infinity or any value greater than or equal to the value of integer dot max value, the result is equal to integer dot max value. Now let's try it out. Let's try rounding the second, and it should return 3 in this case, because 2.8 rounding should go to 3. And we can see 3 here. But if we make this as 4, this should return 2 now. So making it 2.4 should return 2. And we can see 2 here as expected. There is another thing that math provides, which is random function. So random function returns a double value with a positive sign greater than or equal to 0 and less than 1. Return value are chosen pseudo-randomly with approximately uniform distribution from that range. When this method is first called, it creates a single new pseudo-random number generator exactly as if by the expression new java.util.random. So random is another class in Java. So you can either use the random class to generate a random number, or you can use the method provided in math class. Now let's use the random number, and let's get rid of this argument because it doesn't have any argument. It's just going to generate a random number. And let's compile and run. So we can see we got a random number of 0.62200. Let's run again. This time we got 0.74. Again another run, 0.57, and so on and so forth. We can continue using that to generate a random number. And this is pretty useful. Apart from that, this is another useful method we can use, which is power. This is returns the value of the first argument raised to the power of the second argument. So let's focus on the power, and we can say first to the power of second. Let's try it. This is going to give a very long number, but let's run this. And you can see it is 22,064 point something. Let's make it just 2, which is 25 square. And this is going to give us 625 as expected. So these are the most common and useful functions in math, which will come very handy on a day-to-day basis. But apart from that, there are a bunch of other function as well, and there are a couple of constant. So the pi constant is very useful when you need to do any operation with pi. And as I mentioned in the beginning, it also has logarithmic operations, and then it has trigonometric operation like sine, tan, and cos. So this is in a nutshell how we can use the math class to do certain mathematical operation. If you like this video, please give me a thumbs up. If you are new to this channel and you think you are getting value out of this channel, please subscribe to this channel. And thanks so much for watching this video.